Okay, so what this question is asking is it says how much manganese oxide would be added or should be added to excess hydrochloric acid to obtain 185 milliliters of chlorine gas at 25 degrees Celsius and 805 torr. So first, right away, we got to ask ourselves what we are given and then what we need to find. So it gives us volume, which is 185 milliliters. It gives us temperature, 25 degrees Celsius, and it gives us pressure, which is 805 torr. And it asks us to find how much. So that's either grams or moles. So right away, I think of the equation PV equals nRT because that uses all of those variables. So pressure P in this equation, they give us 805 torr. So here we need to convert torr into atmospheres. So we can look this up, but or you might know it to be 760 torr per 1 atmosphere. So for this, we would just do 805 divided by 760, and that gives me 1.06 atmospheres pressure. And then for volume, it gives us 185 milliliters. So this we are going to convert into liters, and it'll give us 0.185 liters, and that's going to be equal to N times R, which is a constant, and it's 0.0821. And then T, which was given to us in Celsius, and we need it in Kelvin, so we'll do 273 plus 25, and we'll get 298 Kelvin. Okay, so now we need to solve for N, which is our moles. So for that, we're just going to do 1.06 times 0.185 equals divided by our R value, so 0.0821 times 298 Kelvin. And this gives me an answer of, it gives me an scientific notation, but I guess it's not really all that big of a deal, so I'll do 0.00802. And that's going to be moles of chlorine gas. That too should be a subscript, but you know what it means. So so 8.02 times 10 to the negative 3, if that is easier for you. But anyways, so now what we have to do is we have to go back to our chemical equation, which they gave us, and it tells us that hydrochloric acid is the excess. So we already know that MnO2 is our limiting reagent. So we know that that is what we are looking for. So what we're going to do is we look at the mole ratio of chlorine gas to manganese oxide. So here we're going to see right away that it's a 1-to-1 ratio, which is really nice. So for every 1 mole of chlorine gas, we have 1 mole of manganese oxide. So for every 0.00820 or 802 moles of chlorine gas, we have 0.00802 moles of manganese oxide. So I'll just write that too. And now we're going to, well, it just says how much. So this never answer moles, but if we want to, we can convert it into grams. It's not really specific, but we can do that because it's really not all that hard. So 0.0820 or 802, geez, why do I keep saying that? Moles of manganese oxide. And then we'll just put that over 1. And then we go to times, and then we're just going to need the atomic mass of manganese oxide, which I found this to be 86.94 grams, and then over mole, 1 mole. And I got an answer of 8.3 grams.